eigenvalues and eigenvectors of a square matrix. Suppose that we are given a square matrix A. Then the eigenvalue is defined as the scalar quantity lambda such that it satisfies the equation A into x equal to lambda into x. Okay. This lambda is called the eigenvalue of A, and this x, is a vector, a non-zero vector, and that vector is called eigenvector. So eigenvalue and eigenvector is defined as when we are given a square matrix A such that it satisfies the equation A into x equal to lambda into x. That lambda is called eigenvalue of A, and the non-zero vector x is called eigenvector. Next thing is okay. Next thing is how can we find out the eigenvalues of a square matrix? Suppose that we are given a square matrix. How will you find the eigenvalues of that square matrix? To find the eigenvalues, first of all, we need to know what is called a characteristic polynomial. Okay. If we know what is the characteristic polynomial, the eigenvalues can be obtained by taking the roots of this polynomial. So to find the eigenvalue, first of all, we need to know what is called a characteristic polynomial. Once you know what is characteristic polynomial, just find the roots of this characteristic polynomial. The roots of this characteristic polynomial will be the eigenvalues of that matrix. So we want to know what is characteristic polynomial of a matrix. The characteristic polynomial can be obtained by taking the determinant of a minus lambda I. So by taking the determinant of a minus lambda I, we will get the characteristic polynomial. Then find the roots of this polynomial, and that roots will be the eigenvalue of that matrix. For example, suppose A equal to 1, 2, 3, 2. Okay. Find the eigenvalues of this matrix. So how will you find the eigenvalues? First of all, we need to find out the characteristic polynomial. So we need to take the determinant of a minus lambda I. And what is a minus lambda I? A minus lambda I means a minus lambda into identity matrix. I means the identity matrix, that is 1, 0, 0, 1. So A is given, A is 1, 2, 3, 2. Okay. So that is a minus lambda I. So this will be equal to 1, 2, 3, 2 minus, you can multiply lambda to every element in the identity matrix. That will be lambda 0, 0 lambda. Now by subtracting, we will get what is a minus lambda, which will be 1 minus lambda, 2, 3, and 2 minus lambda. Okay, that is a minus lambda into I. Actually, what is a minus lambda? A minus lambda is nothing but you have to subtract lambda from the diagonal entries of A. That will gives you a minus lambda. So A is 1, 2, 3, 2. So a minus lambda I will be 1 minus lambda, 2, 3 and 2 minus lambda. That is a minus lambda I. So the actual problem is to find out the eigenvalues. To find the eigenvalues, we need to find out characteristic polynomial first. So what is characteristic polynomial? That is the determinant of a minus lambda I. So determinant will be determinant of a minus lambda I is 1 minus lambda, 2, 3 and 2 minus lambda. So now take the determinant. What will be the determinant? You have to tell me what is the determinant of this matrix.
1 minus lambda into 2 minus lambda minus 6.
Yeah, 1 minus lambda into 2 minus lambda minus 6. So by expanding this, we will get that will be equal to 2 minus 2 lambda minus lambda plus lambda square minus 6. That is equal to lambda square minus 3 lambda minus 4. So we got a polynomial. This polynomial will be the character. So what are the eigenvalues? So we need to find out the roots of this polynomial. So what are the roots? So we can factorize this polynomial. This is a quadratic polynomial. So how will you factorize this? The product is minus 4 and the sum is minus 3. Which can be written as lambda minus 4 into lambda plus 1. Okay. It can be written as lambda minus 4 into lambda plus 1. So the roots are 4 and 1. 4 and not 1, which is
4 and minus 1.
minus 1. So the roots are 4 and minus 1. So the eigenvalues of the given matrix A will be the first lambda 1 equal to 4 and lambda 2 equal to minus 1. These are the eigenvalues of the matrix. So if a matrix is given, to find the eigenvalue, first of all we need to find out the characteristic polynomial. The characteristic polynomial can be obtained by taking the determinant of a minus lambda I. A minus lambda is nothing but subtract lambda from the diagonal entries of A. You will get a minus lambda I. Take the determinant. By taking the determinant, we will get characteristic polynomial. Then find the roots of this polynomial. That roots will be the eigenvalues of that matrix. Okay. So another example. Suppose A equal to 0 to 4 2. Okay, find the eigenvalues. So first find out the characteristic polynomial. For that, we will take the determinant of a minus lambda. Like I said, a minus lambda is nothing but subtract lambda from the diagonal entries. So it is 0 minus lambda, 2, 4, 2 minus lambda. Now take the determinant. 0 minus lambda means that is minus lambda. So what will be the determinant? Determinant will be minus lambda into 2 minus lambda minus 8. So which will be equal to minus 2 lambda plus lambda square minus 8. Or we can write as lambda square minus 2 lambda minus 8. So that will be the characteristic polynomial of the given matrix. Now find out the roots of this polynomial. What are the roots?
4 and minus 2.
4 and minus 2. So this polynomial can be written as lambda minus 4 into lambda plus 2. So roots are 4 and minus 2. So the eigenvalues are lambda 1 equal to 4 and lambda 2 equal to minus 2. These are the eigenvalues of the given matrix. Okay. So we can move on to an example which is of order 3 by 3. A equal to 2 3 minus 2 0 5 4 1 0 minus 1. So that is our A, which is a 3 by 3 matrix. Find out the eigenvalues. So first you have to find the characteristic polynomial. That is, take the determinant of A minus lambda I. So how will you find determinant? A determinant of A minus lambda I. A minus lambda is subtract lambda from the diagonal entries of A. So it is 2 minus lambda, 3 minus 2, 0, 5 minus lambda, 4, 1, 0, minus 1 minus lambda. Now, how will you take the determinant? We can find the determinant in different ways. We can use the first row to find the determinant, or we can use the first column. I am using first column to find the determinant because there is a zero in the first column. You can see that the second element in the first column is 0. So I am going to use the first column to find the determinant. So it will be 2 minus lambda into minus 0 into something. That will be anyway 0 plus 1 into determinant of 3 minus 2, 5 minus lambda 4. So what will be the determinant? 2 minus lambda into 5 minus lambda into minus 1 minus lambda minus 0. That will be 0 plus okay. So it will be, so by expanding we will get 2 minus lambda into 5 minus lambda into minus 1 minus lambda. So which will be minus 5 plus lambda minus 5 lambda plus lambda square plus 12 plus 10 minus 2 lambda. So which will be equal to 2 minus lambda into 2 minus lambda into lambda square minus 4 lambda minus 5 plus 12 plus 10, that is 22. 22 minus 2 lambda. Again we need to expand this. By expanding, it will be 2 into lambda square minus 4 lambda minus 5 minus lambda into lambda square minus 4 lambda minus 5 plus 22 minus 2 lambda. Okay, so this will be 2 lambda square minus 8 lambda minus 10 minus lambda cube plus 4 lambda square plus 5 lambda plus 22 minus 2 lambda. So by simplifying, it will be, there is only one coefficient for lambda cube, which is minus lambda cube. Now add the coefficient of lambda square, that is 2 lambda square plus 4 lambda square, which will be 6 lambda square. Now add the coefficient of lambda, which will be minus 8 lambda plus 5 lambda minus 2 lambda. Minus 8 plus 5, which is minus 3 minus 3 minus 2, that is minus 5. Minus 5 lambda. Then add the constant terms, which will be minus 10 plus 22. That will be plus 12. So that will be the characteristic polynomial. So the characteristic polynomial of the given matrix will be minus lambda cube plus 6 lambda square minus 5 lambda plus 12. So we haven't done it. We have to find out the eigenvalues. To find the eigenvalues, we need to find out the roots of this polynomial. So how will you find the roots of this polynomial? That is our next step. This is not a quadratic polynomial. This is a cubic polynomial. Because our given matrix is a 3 by 3 matrix, so we will get a polynomial of degree 3. If it is a 2 by 2 matrix, then the characteristic polynomial will be a quadratic polynomial. If the given matrix is a 3 by 3 matrix, the characteristic polynomial will be a cubic polynomial. Here we got a cubic polynomial, and now we need to find out the roots of this cubic polynomial. So there is no other method. We have to arbitrarily substitute some values for lambda and find the roots. Okay. So how will you substitute arbitrary values for this characteristic polynomial? Look at the constant term of the characteristic polynomial, which is 12. Right, the constant term is 12, and I am going to take the divisors of this 12. What are the divisors of 12?
2, 4, 6.
2, 4, 6 are divisors of 12. Not only 2, 4, 6, 1 is also a divisor and 12 is also a divisor. So the divisors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. These are the divisors of the constant term in the characteristic polynomial. Okay. So the possible values of roots. The roots will be one of them. Plus or minus, it may be plus or minus 1, or it may be plus or minus 2, or it may be 3, 4, 6, or 12. So to find the root, we will arbitrarily substitute these values into the characteristic polynomial. So I am going to start from 1. So what happens when we substitute 1 into the characteristic polynomial? If we substitute 1 into characteristic polynomial, we will get minus 1 cube, that is minus 1 plus 6 lambda square, that is 6 into 1, which is 6, minus 5 into 1, which is 5, plus 12. So that is actually what? It is not equal to 0. So we can eliminate that possibility. 1 is not a root. Now move on to the next divisor, minus 1. Okay. So now substitute minus 1 into the characteristic polynomial. So what will be this? Minus of minus 1 cube plus 6 into minus 1 square minus 5 into minus 1 plus 12. Is it 0? That will be minus 1 plus 6 plus 5 plus 12. It is also not equal to 0. Right? This when we substitute minus 1, we will not get 0. So we can eliminate that possibility also. So minus 1 is also not a root of the characteristic polynomial. Now move on to the next divisor 2. What about 2? When we substitute 2 into the characteristic polynomial, we will get what? Minus 2 cube plus 6 into 2 square minus 5 into 2 plus 12. So which is equal to minus 8 plus 6 into 4, that is 24, minus 5 into 2, which is 10, plus 12. Is it 0?
No.
No, it is not 0. So we will move on to the next divisor, minus 2. What about minus 2? When we substitute, we will get minus of minus 2 cube plus 6 into minus 2 square minus 5 into minus 2 plus 12. So that is equal to minus 2 cube means minus 8. So minus of minus 8, that is plus 8. 6 into 4, that is 24. 5 into minus 5 into minus 2, that is plus 10 plus 12. That is also not equal to 0. So my minus 2 is also not a root of the characteristic polynomial. So we will move on to 3. What about 3? Minus 3 cube plus 6 into 3 square minus 5 into 3 plus 12. So that is equal to minus 27 plus 9 into 6. 96 is 54 minus 50 plus 12. Which is also not equal to 0. So 3 is not a root. What about minus 3? Okay. Minus 3 is also not a root. What about 4? I think we have made some mistake in finding the characteristic polynomial. Okay. We can find the eigenvalues of this matrix. Before that, I will give you a shortcut method. Shortcut method for finding.
Sir, maybe operation between 22 and 12.
Which one?
22 and 12.
22 and 12.
Might be something.
Minus 4x becoming 0.
Minus 4. Okay, minus 4. Okay, let me check. When we substitute minus 4, that is minus of minus 4 cube. Minus 4 cube is, no, it will not become 0. Minus 4 cube plus 6 into minus 4 square minus 5 into minus 4 plus 12. So actually these all terms will be positive. If we add these positive numbers, it will never become 0. Minus 4 cube is negative, negative into negative positive, plus positive, plus positive, plus positive. So it will never become 0. So minus 4 is not a root. So actually I think I have made some mistake in finding this characteristic polynomial. So let me check. We can use the shortcut method for finding characteristic polynomial. So I will tell you that the shortcut method. So the shortcut method is for 2 by 2 matrix. The shortcut method for finding characteristic polynomial is, it will be lambda square minus trace of that matrix into lambda plus determinant of that matrix. So you have to know what is called a trace. What is a trace? Trace is nothing but it is a sum of diagonal entries. That is called a trace. Okay. So if you find out lambda square minus trace of A into lambda plus determinant of A, that will gives you the characteristic polynomial of a 2 by 2 matrix. Okay. For example, consider the first example we have discussed, 1 2 3 2. Okay. 1 2 3 2. We got the characteristic polynomial as what? Lambda square minus 3 lambda minus 4. Okay, we can use the shortcut method to find the characteristic polynomial. So let me check. The shortcut method is lambda square minus trace of a into lambda plus determinant of a. So by using the shortcut method, lambda square minus trace will be the sum of the diagonal entries, that is 1 plus 2, which will be 3. So lambda square minus 3 lambda plus determinant will be 1 into 2 minus 3 into 2, that is 2 minus 6, which will be minus 4. Okay, so also we can use the shortcut method to find the characteristic polynomial. This will be the characteristic polynomial of that matrix. So the actual way of finding the characteristic polynomial is taking the determinant of a minus lambda. Also we can find the characteristic polynomial by using the shortcut method. And what is the shortcut method for 3 by 3 matrix? Okay. For 3 by 3 matrix, the shortcut method for finding the characteristic polynomial will be minus lambda cube plus trace of that matrix into lambda square. Again use minus of m11 plus m22 plus m33 into lambda plus determinant of that matrix A. This will be the shortcut method for finding the characteristic polynomial of a 3 by 3 matrix. And what is this m11, m22 and m33? These are the minors. M11 means M11. How can we find M11? M11 is obtained by deleting the first row and first column from the given matrix and take the determinant of the remaining elements. That will give you M11. M22 will be what? We have to delete the second row and second column from the given matrix and take the determinant of the remaining elements. That will be M22. Similarly, what will be M33? M33 will be delete the third row and third column from the given matrix and take the determinant of the remaining elements. That will give you M33. Okay. So let me check for the case of the previous example, that is 3 by 3 matrix 2 3 minus 2 0 5 4 1 0 minus 1. So this was the matrix. So by using the shortcut method, what will be characteristic polynomial? It will be minus lambda cube plus trace of a into lambda square. Minus of m11 plus m22 plus m33 into lambda plus determinant of a. So this will become what? Minus lambda cube plus trace. What is the trace of this matrix? Sum of the diagonal entries, which will be, what is the trace? 6. It will be 6. So 6 lambda square minus of m11. M11 will be delete the first row and first column and take the determinant of the remaining elements. So it will be minus 5, right? Plus M22. M22 means delete the second row and second column and take the determinant, which will be minus 2 plus 2, which is 0. And what is M33? 10. That is 10 plus determinant. Determinant will be So find out the determinant of the given matrix, which will be 2 into minus 5 plus 1 into which will be 12. Okay. So which is minus lambda cube plus 6 lambda square plus 5 lambda plus 12. This is the characteristic polynomial. Actually, what we have got there is okay. Oh,
plus 5 lambda.
yeah, it is plus 5 lambda. Yeah, that was a mistake. Okay, it was supposed to be plus 5 lambda. Somewhere I got some mistake. So if you take the determinant of a minus lambda, it is actually supposed to get minus lambda cube plus 6 lambda square plus 5 lambda plus 12. That is the actual characteristic polynomial of that matrix. Now, like I said, take the divisors of the constant term, which are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. And substitute these values into the characteristic polynomial, starting from 1. Okay. By substituting 1, it will be minus 1 cube plus 6 plus 5 plus 12. That is not equal to 0. What about minus 1? That is also not a root. What about 2? 2 will be minus 2 cube plus that is also not equal to 0. When we substitute minus 2, that will be minus 2 cube, that is minus 8, which will be plus 8 square. 24 minus 10 plus 2. So minus 2 is also not a root. What about 3? I think 3 is also not a root. What about minus 3? Minus 3 will be minus 27. Okay, 27 plus 9 into okay. Anyway, we have to check all the divisors of this constant term. We can do it in the next class. Okay. You have to do one thing. Try to substitute all the divisors into this equation. I think maybe the question has some mistake. What about minus 4? Minus 4 will be it is not plus 5. It is actually minus 5.
Minus 5.
Yeah, it is minus 5, right? Okay. So the actual characteristic polynomial is actually minus lambda cube plus 6 lambda square minus 5 lambda plus 12, which was right. Okay, so find out the roots of this polynomial. We are not able to find the roots of this polynomial. I think the roots doesn't exist for this polynomial. So maybe maybe there is some mistake in the question, or we can try this on the next class. Okay. So actually the characteristic polynomial of this matrix is minus lambda cube plus 6 lambda square minus 5 lambda plus 12. That is the characteristic polynomial. Okay. We can discuss some examples on the next class. Okay. Okay. Then thank you, students.